All right, so I'm going to be talking about a couple of measures of location. And the first one I'm going to be talking about is the mean, and then I'll explain what the median is next. Now, the mean is something that we're all familiar with, and another term for mean is the average. And what I have here on the spreadsheet are two formulas, and these are statistical formulas that represent how to compute the mean. One of them is related to sample data, and then the other one is related to the population. And the steps are pretty much the same. It's just the notations are a little bit different. So if we focus on this first one, we have X bar, which means a sample mean equals, and then we have sigma and X. So this is what we use to represent the sum of. So the sum of X in our case is going to be the data points that we're paying attention to. So if we're going to try to calculate the mean of cost per order, for example, each X, so X sub I here, I means the index position. So however many index positions you have related to cost per order, and we have quite a few. So we have plenty of X's that we have to sum up. And then once we sum those up, we're going to divide that by N, and notice it's a lowercase n, which represents a sample size. So this formula that we have in the bottom, same steps to compute the average, but the notation is different. So now we have a mu instead of an X bar. And then we have the sum of X sub I, same thing, divided by capital N. And capital N is, in statistical notation, is the population size that you're dealing with in your data. And oftentimes, we normally have the sample. So it's a subset of the population. And it's a sample that's usually enough to be able to represent the population and make inferences on them to generalize off that population. So what we have here is a sample of cost per orders that come from the purchase orders data set. And I'm just focusing on column G, and I have this over on a different worksheet. And next to that, I have X1, X2, X3, just so you know that this is what we have here, where it says X sub I, meaning in our case, X sub 1 would be the first data point, which represents 2,700. X sub 2 would be that'd be the second data point, that'd be 19,250. X sub 3 would be the third data point. This would be 15,937.5, and so on. So that's how you would want to read it when you're looking at these formulas. We really don't need this to compute the average. It's just there to illustrate what we mean by these formulas here. Now I'm going to go ahead and compute the average for cost per order. And even though there is an Excel average, an equal sign average function, I'm going to manually go through this based off of what the formula is doing here, just so you know exactly what's going on in the back end. So the first step is to sum the cost per order values. So here are all the values. So the sum of xi, so all of these values that we have here. So before I do that, I'm just going to go ahead and give this a name range so I can be able to refer to this a little bit easier. So I'm going to select all of these data values, and I'll say CPO for cost per order. And I'll just refer to it like that from now on. So when it comes down to trying to get the sum of cost per order, this numerator, I'm going to say equal sign sum using that function. And I want to add all of those up. So I'm just going to put CPO, since I did give it a name range, and hit enter. So this is the total amount when it comes down to cost per order. I could also give it a currency, since we are dealing with money here. And then the number of observations is the number of cost per order data values that we have. And if you notice here, we're starting off at the first data point, which is X sub 1. And all the way down, we have 94. So we have 94 observations, but there is a function to do this. If we did not have this column, let's say, for example, it was hidden, and we want to know the number of observations, and we could just count, just that count function or count all. We just count A, and I will say CPO, select that data. We have 94 observations. Now to get the mean, I will divide the sum of X divided by N. So here's the sum of X divided by N. And this would be my average. So this is what's going on in the back end. Now, the shortcut method is equal sign average function, select the data, and we have the average. I'm just going to go ahead and format this. There you have it. the mean is sensitive to outliers. So if you have values that are unusual and not really consistent with the values that you have with the rest of the data in your data set, then it can kind of throw off the average value. And so one of those measures that accounts for outliers and tackles that issue is a median. And this is another way of figuring out what the center point is more or less with your data set or those particular values of the variable that you're paying attention to. There is a function for this, which is equal sign median. And now, if I were to select all of these values, hit enter, this would be my median for this data set here. But manually, if you're trying to figure out the median, what you would do is if your data set is not ordered, then you would want to first make sure that you sort it out. So you'll notice in the mean tab that the data here is not really sorted. But here we do have them sorted out. Now, I'm just going to go ahead and say median here so we know what we're doing. But let's say, for example, we're not using the median function, then we know that the count is 94, right? So if we're trying to get the median, what we do is we will say 94 observations divided by 2, which is 47, and that would represent the index position 47. So we have these ranks here, and if we go down, we have 47. Now, because we have an even number of observations in this example that we're dealing with here, then what you would want to do is focus on the two middle values. So if we get these two values and divide them together, this would represent the median. Now, we do have some outliers in the data set, and these right here that have these very small values in comparison to the thousands of dollar values that we have, which can throw off where the center point of your data would be. So I'm going to go ahead and just type in mean, and I'm going to get the average again. And I just want to demonstrate, let's say if I were to substitute for this first value, instead of it being $68.75, I'm going to say 0. And notice when I did that, my value is changing, but my median isn't. So let me just do a couple, instead of 0, let me say $5. Several ones here. Notice that every time this is changing, my mean is changing, but my median is still the same because it's paying attention to that middle number that I have when the data is sorted out, when those values are sorted out. So this is what we mean by median is a good method of measure of location if you're dealing with outliers in your data. Now let me go ahead, before I conclude this video, just talk about the mode, which is another type of measure of location. So I'm going to hit equal sign mode, and I have two options here that I would want to choose from. I have the dot multiple and then dot single. And really, you just have to assess the data, and if you feel like there's going to be multiple modes, then you would want to select this one. But it's a little bit of a process in comparison to the dot single. So if I were just to choose that dot single and select this data that I have here, it will shoot out and let me know what is the value that is shown the most in this data set, which is the value number 5. Now, there could be two different values that are appearing the same number of times, right? So that's one of those things that you would want to pay attention to if you're trying to figure out the mode. And if that is the case, now let's say, for example, I'm going to change this a little bit, and I'll say 5, and then I'll just put any number here just for demo purposes. Now we have two values, two unique values that are appearing at the same time. And the way that you would have to do this, if you believe that there's going to be multiple modes in your data set, you would want to select a few blank cells. So if you think that there's going to be 2 or 3 modes, then you would want to select 2 or 3 blank cells. So let's go ahead and select 4. And I'm going to hit the equal sign and then type in mode, and then I'll select MULT. Now here, I'll select the data set, and I'll just go ahead and do a subset selection here. So I'll just select these values, these first 10 values, and close the parentheses. Now, I don't want to hit enter because it will just populate one mode. So I would have to hold down on my keyboard the buttons Control, Shift, and Enter. And you'll notice that there are two values that got populated. So the number 5 and 55 would represent the mode and what I just selected. And then these NAs are just basically letting you know there are no other modes. So it's a little bit tricky when you're using the mode function, but hopefully this gives you some clarity. So there are four measures of dispersion that I'll be talking about in this video. So I have the range, interquartile range, variance, and standard deviation. When we're looking at the cost per order, and this is based off of the data set related to purchase orders, and I'm focusing on column G. And the range is taking a look at all of the cost per order values, and it's paying attention to the minimum value, so the minimum cost per order, and then the maximum cost per order. And it's taking the difference between those two. Now, I could sort this information here out, or I could use the maximum and minimum function together and get the difference between the two. I'm going to use the max function. And just to kind of simplify things, I'm going to create a name range for cost per order. And I'll call this cost per order, the abbreviations there, and I'll hit enter. So when I say get the max and the max within cost per order, I'm going to say subtract that from the minimum cost per order. So I'm using two functions together, the max and the min, getting the difference between these two values, and this would be my range. Now the interquartile range has to deal with the quartiles. When you're trying to get the interquartile range, we're trying to look at the range of the first quartile as well as the third quartile in the cost per orders. So I'll go ahead and say for the array, I will select cost per order, and I want number one, the first quartile. I'll do the same thing for the third quartile. Okay, let me go ahead and just give that a format and widen these columns a little bit. So now that I have these two values, I'll just subtract these two values together, and that would give me my interquartile range here. So I'll select that value, subtract it from that value. Now I have my interquartile range. Then the variance is there's a formula for this that I will be talking about in more detail. The Excel function to get the variance is var.p and var.s. So the variance is another way to try to measure the spread of the data that you have here, but it's really hard to interpret just because this value gives you the result in units squared. And so it's really hard to get an idea of what this value is telling you. But this is going to be very useful for other types of statistics that you will be dealing with in another course. But let me go ahead and demonstrate how to use this function. Let's assume that we are dealing with a sample. So I will select var.s. And for the data, it's going to be everything related to cost per order. And this is the value that I get. Now see how large that value is. Really hard to get an idea of what this means in terms of the spread of all of these values. Now, because we can't really get an idea on this value alone, if we were to square root this value, this would be, and so let me go ahead and do this. I'm going to do a SQRT on that variance value. Now, that makes a lot more sense if we're trying to get an idea of the average spread of the data that we're looking at here, which is around $30,000 when it comes down to the cost per order. Now, the SQRT function is not the main standard deviation function to use in Excel. There is let's see here, the stdev.p and .s. And again, this is one of those things where you have to understand the data that you're dealing with and ask yourself, is this a population data set or is this a sample? And normally you're dealing with samples. Select that data inside this argument, hit enter. And this is the same value that I got when I square root the variance, right? Now, the range is a quick and simple way to get an idea of the spread of the data, but the problem with the range is it is influenced by outliers, and they're only really using two data points in this data that we're interacting with to say that this is the spread. It could be useful to have, but it's not the most reliable. The most common type of measure of dispersion would be the standard deviation because it does include every single data point when it's trying to account for that average deviation, that measure of dispersion that you're trying to understand in your data. Continuing on with the measures of dispersion, I want to go ahead and calculate the variance and standard deviation manually, and I've provided the formulas for each one of these. Now, let me just make these just a little bit bigger. Right. So the formulas that you see on the left, these first two right here, represent the variance. It's really important to understand what's going on in the back end when you are using the functions, the Excel functions to get the variance and the standard deviation. So one on top is when you're dealing with the population. The one on the bottom is when you're dealing with the sample. And when you go on and try to select a variance function on Excel, you do have a .p and a .s for population or sample. And you can see that there are differences here, not only in the notation, but in the step. And one of those happens to be the denominator. So if we're doing this manually, even though the variance won't make much sense to us, as long as we square root that value, that becomes a standard deviation and we get an idea of what's going on. So column B and column C, I created a couple of headers so you know exactly what I'm doing here. So I have xi minus mean. Xi is the x value. I can think about it as the x sub I that you see here in the numerator, where we're trying to get to deviations where it's the data point minus the mean of that data that we're looking at, and then we square that result. So I have them in two steps. First is a deviation, and then the square of that result. So the first observation that I have here, I'll just work on that formula, and then I'll just use a filler option for the rest. So this data point that I have here, I want to subtract that from the average of 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 this data here. Now, different ways you can approach this. I could just go ahead and call the average function and select the data here, which I will. Now, I do have a name range and I have it set as CPO and close parentheses, hit enter. So this is the deviation that I get. Because the mean is greater than what I'm subtracting here, I'm going to get a negative result. Now, the next step is to square that result. So I could hit the equal sign and select this value, and then I can select the hat symbol and the number 2 on my keyboard and then hit enter. Now I have this value. So now I'll just go ahead and populate this. So I've taken care of the numerator part. And since we are dealing with a sample, I am focusing on this box right here. Right. So I took care of the numerator where I'm getting the deviations squared. Now I need to sum up the results here. So I have to go down to this column because it's saying sum up all the deviations squared. And then once you sum up all the deviations squared, divide it by the sample size, which is that lowercase n, minus 1. So let me go ahead and go all the way down and widen my columns a little bit. And I'll use the sum function on all of these values that I have here. And this is what I get in terms of the sum of the deviation squared. So I would want to, the last part is this value that I have here, I need to divide it by the sample size. So the sample size, I could say count or count all, either one, and I'll select all the data values. I know there's 94 of them, but I'll just go ahead and include that in my denominator. So it'll look for that. And this is the value that I get here. So let me just go ahead and format this. And this would represent the sample variance. Now, just to validate, I could say var.s, and this is going to be the shortcut formula to use. And I have a name range for that. So that is called cost per order. Select that, enter. And let's see, there's a difference here. So when I did the var.s, I got this value, but when I did manually, I got this value. So there's one step that I forgot when I was calculating this manually, and that was the it's supposed to be n minus one. So I just have n here in the count all. So let me go ahead and say, so now that I account for the n minus one, it has the correct value that I have when I use a shortcut formula. Now, again, this is the variance. It's giving us an idea of the spread, but it's in units squared. Does it make sense to us? So if I were to square root the variance, this would be my sample standard deviation. Now, the shortcut for that would be stdev.s, and I'll select the data, and I get that value. Right. Now, I'm just going to hit the control tilde so you can get an idea of all the different functions that I'm using here, right? So I'm going to go all the way up, and things shift a little bit, but you'll notice this is the approach that I took. I use a name range to calculate the deviation. Then I have the deviation squared. I go all the way down, and then I sum up the deviation squared. Then I divided that value. I divided that value by the sample size minus one. And then I got the variance function, square rooted it to get the standard deviation, and so on. So this is a very common method to use when it comes down to assessing the spread of your data. It is sensitive to outliers since we are dealing with every single data point when we're trying to compute the spread.